Now the RCP software, it's once again, you probably know this already. So from the software, we can visualize the real-time values of the sensor. We can configure specific parameters of the sensor. We can download the log files. So these are the data that is stored in the sensor electronics every day, right? What is usually important in the RCP for the DVM is the thermal control tool. I should actually add a slide on that here, but the thermal control tool is not, you can see it here, it's thermal control tab. It's password protected, and I think you have to enable it through the config file of the RCP. So if a client opens the RCP and does not see the temperature control, it might be because the ini file, the initialization file of the RCP has not that enabled. That can be easily enabled by the client himself. The temperature control tab allows them to integrate to the DTCM. So we will, now if we jump to the application, here we have the DTCM. This is the thermal control chamber for the DVM. You place the DVM here. It has a cover that is not in this picture, but the cover is required for the thermal equilibrium to be achieved. So how do you control the temperature of this device? If this is a heating cooling system, so this we call the DTCM Peltier version, you can do that through the RCP software in the temperature control tab. Okay, there is a DTCM variant that is the external bath that uses normally a Julabo bath that is external. And there you can use the RCP thermal control tab to monitor the temperature basically, and also control the temperature runs that you will do. Okay, I jumped this section. Well, but this is the PVT system that I mentioned before. These are pressure, volume, temperature studies that we enable with the DVM. Yeah, additional use cases, as I said, I believe we have clients studying or using the DVM for additional applications. We are doing studies in gases. So we cannot really say that the DVM has been proven in gases, but it's something that is ongoing. Okay, so now I will show you some real examples of the setup. This is something that I have added for this presentation because I think it's useful. You can see in this picture already how this does not look like a proper installation. In this case, the client was doing a study of multi-phase fluid. It had water, oil, and gas. And you can see the green plot is from the DVM and the orange is from an external density meter. This was the setup that they were using. We recommend them, of course, to change it to first ensure the thermal distribution in the DVM, so control the temperature, and also be aware that some vibrations, I think the client was using a pump down here, might be adding some vibration to the DVM. So that may explain the noise that we can see here. Still, this client was using the DVM as a trial. They did tests for a couple of months. They returned the device, and a year later, they contact us back to ultimately purchase the unit. And in that case, we at that moment we already had the DTCM. So the DTCM in this case is external bath. You can recognize that because it has the external hoses that is going down here with the bath, the Julabo bath on this side. So this ensures the thermal distribution in the DVM. You can also see here the pressure gauge and the volumetric pump to recirculate the fluid. And you can see here also the SME box on the bottom. What were the results? So you can see that The client came back to us reporting deviations in the readings or the expected reading on viscosity. The viscosity percentage of error was higher than 50%, whereas for density was very low, right? So we contact them. We had a call. We asked them to clean the sensor because the viscosity, usually when there are deposits in the sensing element, viscosity tends to be much more affected than density. And in this case, we could see that even at changing temperature, the delta percentage of error was similar, was not changing much. And density also kept very in the lower, it was still okay for the error percentage in density. So we asked them to clean and they did. They said that the errors were still there. We asked them for pictures of the sensing element. They shared something like this. We could see here some deposits, apparently some layers that might be sticking in the sensing element. We asked them to clean again, and apparently it worked. I say apparently because Danny visited this client and everything went well. They ran some more tests in hydrogen and I don't know what other fluids that they test, but the client was ultimately happy with the device. So we don't have data. Of course, the clients just report us when they have bad data, but when they have clean data and good data, they don't usually report that to us. We might need to contact them to get the data. And then we have another client that is also using the DTCM bath version. It has the external bath down here. They are still in testing phase. They have test and decaying fluid. They report a deviation. So you can see here the viscosity and the density. They are a little lower than what they expect for end decaying. So we're still looking into that. However, they also test with another fluid, a reference standard, and here they got very good readings or errors within the expected accuracy of the device. Another topic that we are recently seeing is that, for example, in this client, the Peltier, the Jolabo bath is not cooling properly. So when they order the DTCM, they ordered it with the DVM, right? We can supply the Jolabo bath, or the client can use a external bath that they want. In this case, they got the Jolabo bath from us, and they report that the cooling is not properly done. Okay, heating up the device is fine, but cooling down is not working. Julabo also report that the fluid that they were using as cooling fluid or thermal fluid is not the recommended one for this Julabo bath. It's weird because for the other clients had worked fine. But yeah, just for you to know that sometimes the Julabo bath might show some issues, but that's something still we're investigating. Okay, so that's all that I have for the training. If you have questions, you can ask. That's all, yes.